So proportion math leads us into what we call percent math. Percent is going to be a special ratio. It's going to be per 100. So a percent can be expressed as a fraction or actually a decimal for that matter. So by definition, 25% means 25 per 100. So remember that little percent symbol, this little percent symbol means per 100, or in other words, divide by 100. So it becomes that fraction. And again, if I reduce it, we know that I can divide both by 25 and I could reduce that into 1/4. So as a lowest terms fraction would be 1/4. On the calculator, you can use the N over D button to do that. And if you have the GD formula sheet, you can look more about that N over D button on the GD formula sheet if you like to use the calculator to do fractions. So it's on the, actually it's the GD reference, the calculator part of it all. Formula sheet's on one side, the reference sheet, the reference for the calculator is on the other side. 25% again means 25 per 100, or in other words, 25 divided by 100. But when you divide by 100, remember with decimal math, dividing by 100 means you just put the decimal at the end, since that's where the ones at the end of the ones place. And dividing by 100 means move the decimal 2 places to the left. So 25% is the same thing as the decimal 0.25. So changing percents to decimals is rather easy. All you have to do is move that decimal 2 places to the left, and that does it. So 12% as a fraction would be 12 out of 100, or 12 over 100, if you will. A common divisor, I could see a 4 goes into 12 and a 4 goes into 100. So 4 goes to 12 3 times, 4 goes into 125 times. And again, if you use the N over D button on your calculator, all you gotta do is hit that button and just follow the keys there, but it's pretty straightforward how to put a fraction in the calculator. 12% is a decimal. Again, all you have to do is move the decimal 2 places to the left and just drop the percent symbol. So 12% is the same thing as 12 hundredths as a decimal, or as a fraction for that matter. So percent again means per 100. So that's the magic number there for percents. It's always over 100. As you will see in the upcoming lessons, percent problems have a lot of, they're basically going to be all word problems for the most part. So this is really where you start to see a lot of the math take place in the real world, is percent math. So percent problems are going to have basically 3 elements. So 3 key things. The base is one of the elements, which we also call the whole or the initial amount. The part is the other element, and then the rate or the percent is the third element. The rate actually makes one side of the proportion, because the rate's going to be something over 100. So that's going to be a key part. So when I use proportion math, the rate is actually going to be one side of the proportion. Just looking at some basic percents, 6% is the sales tax rate in Kentucky, which turns into a ratio, $6 tax on every $100 spent. So percent rates will always be over 100. So 6% means 6 per 100. So when I write it as a fraction, I drop that percent. So the 6 is our rate of percent. So we write that as 6 over 100. $6 spent, or $6 taxes on every $100 that you spend. A common discount we come across is 20%, which also translates into a ratio. 20% would mean $20 off per $100. So I can write that as $20 for every $100 that something costs. You get to take $20 off of it. So we start to pick up on that language. So that's kind of working our way about the rate part. Let's see if we can talk more about the base and the part. So the base will always be the whole or the initial amount before anything really happens. The part will be described as a piece of the original amount, either being added on like a tax or removed like a discount. So to get a better understanding of those, you really have to see it in the form of a problem. So at a restaurant, Jake's bill is $20. He gives the waiter a tip of $3, which is 15% of the bill. Identify the three elements of a percent problem. So we want to identify the part, we want to identify the base, and we want to identify the percent, the rate. So the part is something being added on or removed, like a tax or a discount. Or in this case, a tip would be what's added on top of the bill. So to me, the tip would be added on, so the 3 would be the part. The base is always like the whole number or the initial amount before anything happens. So, Jake's bill was $20. That's the whole amount of the bill or the initial amount. So that's where the base is. It's kind of the whole or the initial amount, 20. The percent is clearly the rate that you're supposed to tip your waitress or waiter. So that's going to be a 15%. So 15% would be your rate, your percent. So if you can identify the 3 parts of a percent problem, it's going to take you to the level of actually solving percent problems. So to better understand percent problems, let's look at an example. At a manufacturing plant, smoke detectors are expected to be assembled, and it's expected that 2% will be defective. If 800 alarms are assembled each day, how many are expected to be defective? So basically what we're trying to do is figure out what's the base, the part, and the percent. Again, the base is the initial amount or the whole amount. The 800 alarms are assembled each day. That's going to represent the whole amount or the original amount, which again we call the base amount. The part is going to be what's removed and things like that. So the defective or what's going to be removed in this case, taken away, since it's talking about defective. We don't really know that. That's going to be the unknown. That's going to be our X. And the percent, 2% are going to be defective. So in this problem, the part is actually the defective part. The percent kind of tells you what the part actually is. So if you follow along with the label of the percent, that's going to be the label of the part. So 2% will be defective. That's going to tell you what the part's about. Defective. And we don't know what are defective. So when I do this problem in proportion math, the way we do it is the percent is going to be the 2 out of 100. So what this means is 2 are defective out of 100 alarms. So that tells me that when I come over here, the part has to be on the top, which is going to be X. And the whole, the base, is going to be on the bottom. So what we pick up on is, the part will always be on the top because it's got to match the way the rate works. Part over base. And then on the other side, you're going to have basically the percent over the 100. So the rate over 100. So when I solve the problem, what we have is 100 times X, because we cross multiply to solve it. And that's going to equal 800 times 2. Which is going to equal then 100x is going to equal 1600. Then if I solve that equation for x, I have to divide each side by 100. So if I divide this side by 100, we end up with then 16. What again I could do is use the calculator, because since I have my proportions set up, I can just type it in as, because the diagonal numbers, we just multiply them together, 800 times the 2, and then we divide by the 100. That gives us then our 16. So since we have a proportion set up, we can just take advantage of the calculator as well. So 16 were defective. I'm just going to abbreviate that here. Okay. So as I saw previously, we can use a proportion to solve percent problems. And again, it was basically the part over the base is equal to the percent piece over the 100. That's the proportion model that we talked about. Percents can also be solved by a formula. The part can be found by multiplying the base times the percent. A lot of times this equation is modeled using a triangle. So if I draw like a little triangle over here, it's going to be in 3 little pieces. The part goes on the top, and then it's going to be the base times the rate, which is usually going to be the percent. So let's look at the example here. A company offers its employees 2 health plans. In a recent report, the personnel department stated that 70% of the employees chose Plan X. If the company has 420 employees, how many chose Plan X? So again, in a percent problem, there's these 3 basic elements: the part, the base, and the percent, the rate. So in this problem, the 420 employees is something that I see. That's a known fact. But that looks like the whole amount of the employees. That looks like that's going to be the 420 as the base. The 70% chose Plan X, so the percent's going to be 70%. They chose Plan X. So the part must be about Plan X, and we don't know what that is. So again, the percent tells me what the part is as well. Since the part was talking about Plan X, the part is also about Plan X. And we don't know how many chose Plan X. So that's going to be our X, if you will. Now, to use this formula, though, the percent has to be changed to a decimal. So I'm going to have X equals then, the base is 420, times then 70%, which is going to be, I have to move the decimal 2 places to the left, so it's going to be 0.70. So 420 times then 0.70. And again, you could have left the part as just a capital P if you want to, if you don't want to put an X there. That's just the unknown. So if you like to put that P there, you can instead of the X. So since I already have a variable, we could just keep it as P because we don't know it. So the P stays in the problem. We replace the base with the 420 and replace the percent with the 0.70. So again, once I have the equation set up, I can just use a calculator and do the math. So 420 times 0.70 is going to equal then 294. So the part is going to be then 294 of the employees chose Plan X. So a portion of them chose the plan. So that should make sense. Out of 420 employees, most of them chose Plan X, so that looks pretty good. So as we move more into percent problems, let's look at this example. A company computer system is regularly priced at $1,600. On Friday, the manager reduced the price $480. By what percent was the price decreased? So again, we have to identify this part, base, and this percent. And again, what you can also do is use what I refer to as the triangle model as well. So the part, the base, and the percent. The way this model works is if they're side by side, you're going to multiply. If it's top to bottom, that's going to be a division problem. So let's see what we know and don't know. So again, I'm going to draw my little triangle over here. And I'm going to leave it empty this time. And then I'm going to fill it in with what I know and don't know. So the part, it looks like the percent was the price decrease. So we're looking for the percent. So the percent is going to be left alone. We don't know what that is. The part is going to be the 480 because that's the part that was decreased by. And then the base was the whole amount. So the whole amount of the computer was actually, or the original amount was 1600. So based on our formula, the 480 will go here and the 1600 will go here. And what this little triangle model says is since this is top to bottom, this tells me that all I got to do is divide those two numbers to get our answer. So using our calculator, the 480 goes in, and then I just divide it by the 1600, and that gives us then this 0.3. So 0.3 is our answer, but remember in the formula, the percent was represented as a decimal. For our problem, it must be changed back to a percent because they're asking for the percent, not in decimal form, but in percent form. So to make it a percent, you still got to move the decimal back 2 places to the right. So that becomes then 30%. So there is a 30% reduction in price. So if I took 30% of 1600, that should give me the 480. So let's look at another example and see where this takes us. In a math class, 75% of the students got at least a B on their final exam. So got at least a B, that was their grade on the final exam. If 36 students earned at least a B, how many students were in the class? So the percent's pretty obvious, it's the 75%. And notice that the percent also is describing the part. 75% of students got at least a B. 36 students earned at least a B. Well, that means that that's the part because that's what the percent was describing. So the percent describes the part as well. The base is always the whole amount. And again, it's asking how many students were in the class. So that would be our unknown in this problem. So if I'm using my formula, my little triangle, in our triangle, again, you may have to make it fairly big. I didn't make mine big enough last time. You know, the part has to go here, the base has to go here, the percent has to go here. So when I do my triangle again, the part is 36. The base we don't know, and the percent is 75%. But remember, if you're using the formula, you have to change that to decimal, so it turns into 0.75. So when they're like this, this tells me to actually divide. So I can solve it by just simply typing in 36 divided by 0.75 into the calculator. So it's going to be 48. So there were 48 students in the class to begin with. So 48 students were in the class. And then 75% of them got a B, which was 36 students. So that math should make sense as we read it out loud. So let's look at this example again. Can't tell if I recorded it or not, so let's try it. The workforce at Westland Incorporated is growing rapidly. The number of employees this year is 225% of the number last year. If there are 180 employees this year, how many employees did the company have last year? So again, you know, the easiest number to identify is the 225%. So we have 225%. And if we're using the formula, that changes to 2.25. So you have to move the decimal 2 places to the left to make it a decimal. Now what helps us out is the percent always helps us identify what the part is. It's 225% of last year. If there are 180, let me see if I did that again. So If there are 180 employees this year, how many employees did the company have last year? So again, I think I misread that again. The number of employees this year is 225%. So notice that this year goes with the 225% of the number of employees last year. If there are 180 employees this year, how many employees did the company have last year? One of the things to pick up on though is if the percent is over 100%, that means the part is going to have to be bigger than the base. So based on the way I'm reading it is the 225% is going with this year. So that means the part is going to be the 180. And what we don't know is the base. And sometimes you may have to do the math more than once because I know the answer, the part's got to be bigger than the base because of the 225%. So the 180 goes here, that's this year. The base is usually always the last year, so that makes sense. The original amount, we don't know it. So using a calculator, I can put in then the part, which is the 180, and if I divide it by the percent, the 2.25, that should give me the base of 80. So that makes sense, 80 employees, because our employment went up. So it went from 80 employees up to 180 employees. So that's a nice increase. So there's 80 employees last year. So another type of percent problem we'll get into is what's called simple interest. It's going to be on the GD formula sheet as well. So if you see the word simple interest in a word problem, that's going to be a signal that, hey, the GD formula sheet has that formula. So it's going to be a very special percent problem because simple interest is going to involve what's called a time element as well. So what's going to happen is, interest is the part you're going to make off an investment, or it's the part you're going to have to pay if you borrow money. And the principal is going to be the amount that you invested or borrowed. So keep that in mind when you borrow money or you invest money, it's over a period of time. So interest can be calculated by using the following formula. Interest is going to equal the principal, which again, the principal is the amount you actually invested or borrowed, times the rate, which is going to be that percent. But again, in formulas, the percent is usually in a decimal form. And then we also have this time, and this time has to be in years. So our unit of time has to be in a yearly time. A lot of times in the GD formula sheet, the formula will be written in this form right here, where I for interest equals the principal times the rate times time. So P will be the principal, which is the amount borrowed or invested, and the rate will again be your percent, but remember it's got to be in a decimal form, and then your time is going to be in a year, in years. So let's look at this example. Ellen borrows $2,500 from her aunt for 3 years at 6% simple interest. There's that word, simple interest. So it's going to be a clue that, hey, I can use this formula. How much interest will she pay on the loan? So they're looking for how much interest. So the I is going to be unknown. The principal is going to be what she actually borrowed, which is going to be the 2,500. The rate is going to be 6%, or in other words, as a decimal, it's going to be 0.06 because you have to move the decimal 2 places to the left. And the time is in years, so it's going to be 3. So in our formula, I is going to equal then, and it's going to be this 2,500 times the 6% in a decimal form times then 3 years. So again, we start to use a calculator for all this. So we go 2,500 times 0.06 times 3, hit our, on the GD calculator, it'd be the word enter. Here it's equals, and it'd be $450. So the interest would be then $450. So when Ellen borrows $2,500, she'll pay back the $2,500, but she's also going to have to pay back an additional $450 for borrowing the money. So her actual amount total would be actually what, 29,000 or $22,950. $2,950 would be her total loan over a 3-year period. So you don't just pay the $450, but you also got to pay back what you borrowed. So again, let's look at this question. As you can see, percents have a lot of word problems. So Eddie invests $3,000 for 9 months. He will earn 8% simple interest on his investment. How much interest will he earn in interest? So how much interest will he earn? Okay, so let's see what we have here. So again, we see that word simple interest. We don't know what the interest is going to be again, but we do see that he's investing $3,000. We also see that his rate of interest is going to be 8%. In a decimal form, that's going to be 0.08. And then the time is going to be 9 months. But notice that time is supposed to be in years, so we have to pick up on that. You know, there are 12 months in a year, so 9 months is actually a fraction of a year, and therefore time must be expressed as a fraction. So time is actually going to be 9 months out of 12 months. And if I put that in lowest terms, that's going to be like 3/4. And since I know that's 0.75, I'm going to use 0.75 on my calculator. Now in the GED test, you have that N over D button, so you could probably just take advantage of that N over D button on the GED. And again, the GED calc reference sheet helps you use that button if you need a guide. So for me, my interest is going to be this 3,000 times 0.08. That's our interest rate. And the 9 months is actually going to be a fraction of a year, or in this case, I'm going to change it to a decimal. Its decimal equivalent would be 0.75. So I can put that in the calculator, and it should give us the interest that he made off of his investment. So I'm going to have to move this out of my way, though, so I can see my problem. So 3,000 times 0.08, which stands for 8%, times 0.75, and that's going to equal then $180. So he's going to make $180 off of his investment. Now keep in mind, not much time has gone by, so you shouldn't be making a whole lot of money. So that number cannot be very high to begin with, just using your own common sense. So you're not going to make $3,000 in 9 months off of $3,000. It's only 8%. 8% is not very much. So you should be looking for a small number as well, and that seems reasonable. So he's going to make he's going to make $180 off of this investment. So the last of the percent problems we're getting into is some percents are often used to show what we call a change. You know, percent of change compares a new number, which will either be an increase or decrease, to the original number. So this is going to be called a percent increase or percent decrease. And a lot of times you'll see that with like the COVID virus. Right now you'll hear them, though, that's a change of this percent, things like that, or it's an increase of this percent, or it's a decrease of this percent. So we see that a lot when we start to follow the 2020 COVID virus. So we're not going to go there today. We're just going to look at some more simpler questions. So let's look at the example. Before her raise, Lisa earned $10.50 per hour. Now she earns $11.13 per hour. What percent raise did her supervisor give her? So again, we're looking for a percent raise. So again, the percent is about the raise. So with percent change problems, we pick up on this is going to be an increase problem because it was a raise. Subtraction may be needed to use to actually figure out what the increase actually is. So to find the increase, the actual raise, I have to go 1113, and And I may have to subtract the 1050. And again, if you want to get lazy, you can use the calculator. 3 minus 3, 0 is 3. I can borrow there. Make that an 11. So it looks like that's a 63-cent raise. Again, you could verify that with the calculator if you get kind of tired and punchy. So 11.13 minus 1050 equals 63 cents. So yeah, did that right. So 63 cents is going to be our part. And the base is going to be the original amount. So this is going to be the part here. So P is going to be the 63 cents. And the base is going to be the original amount. So the original amount was the $10.50. That was where she started at. So the base amount was the original amount, the $10.50. So again, to do this problem, I can again use my triangle. The base is going to be that 0.65. The base, the part was 63 cents. I'm sorry. Let me try that again. Getting a little too sloppy. Okay. So let's draw a better triangle there. Need something bigger. Something that can hold a bigger number. So the 0.63 would go here. That's our part. The base is the 1050. So again, I recognize that since this is top and bottom, that's like a fraction bar. That means to divide. So on my calculator, I'm going to have 0.63 divided by 1050 equals then 0.06. So our percent is going to be actually not the 0.06, but actually, because you got to move the decimal 2 places to the right to put it in percent notation. Because remember, the formula actually is making in the form of a decimal. So then that turns into a 6% increase in her pay, which makes sense because she didn't get a huge raise. It's just a 63-cent raise, so that's not going to be some massive percent. So that answer sounds reasonable. So again, I can use the triangle model, but again, for the part, you have to identify either the increase or the decrease, and you have to pay attention that the base is actually the original amount. So there may be some math you have to do before you can actually use the triangle model. So this takes us to our home stretch. We're going to do another percent increase or decrease problem, I believe. Let's see what it takes us. So a leather jacket is on sale for $90. 3 days ago, the jacket was on sale for $120. By what percent was the price reduced? Notice again, they don't use the words increase or decrease, but we do see the word reduced. So by what percent was the price reduced? We pick up on that this is a decrease problem. So they have those synonyms. So this is going to be percent decrease. So the part is going to be the decrease. So what is going to be $120? Then it was $90. What we have to do is figure out, well, how much did the price go down? So to find that decrease, we actually got to subtract those two values to find how much it actually went down. So it looks like that's going to be $30. So the decrease is going to be the part. The base is going to be the original amount. So the original amount, well, you know, it's on sale for $90 now, but 3 days ago it was on sale for $120. So the original amount is actually going to be that 120. That's going to be the base. So we're going to be looking for the percent change. So what's that actual change? And it's going to be a decrease as well. So again, if I use the triangle model, which by now you already may pick up on the pattern, well, this is just simply a division problem. So the 30 was the actual decrease. That's our part. And the original amount was the 120. And so when I do the math, I just got to remember that's like a fraction bar. That's a division problem. So I use my calculator. 30 divided by 120 equals then 0.25. But remember, that's in decimal notation. I still got to put it in percent notation. So if I move the decimal 2 places to the right, that creates then the 25%. Because you remember 25% means 25 per 100, and that would be equivalent. So that concludes our lessons on ratios, proportions, and percents.